Hi, welcome to that presentation. Today I'm going to use the Photon Plus, which is sitting here on the right of my desk, and I'm going to use an impact hammer, which is sitting there, and a little teardrop B&K accelerometer, and I'm going to do frequency response measurements. So I'm going to hit the I-beam here and collect the trans function between the hammer and the accelerometer. All right, guys, let's play with RD Pro here, and I'm going to do a frequency measurement response. I'm going to use the model data acquisition, which is already pre-configured for me. All right, so where to start? On the top right corner here, there's the signal buttons. So time capture is checked, power spectra is checked, the cross-channel signals are checked, and I'm using the channel 1 as a reference. I'm going to do a trans function, H1. I'm going to use the excitation as a reference here in my case here. So no waterfall, number of lines, and frequency can be changed. So this is my FFT parameters. So let's do maybe 1,000, let's say 2,000 hertz with, let's say 800 lines. So give me 248 points in my time capture. And the frames, I'm going to use a single or multiple frames actually. Why multiple? Because I want to capture 3 averages, right? So I want 3 frames in order to make an average. So that's why I'm using multiple. The window, obviously this is adding here is totally wrong. I have to select known. And under the channels, I want to use a 1 volt for my hammer and 1 volt for my accelerometer. So this is force, this is acceleration, that's correct. So the engineering unit here is LBF. And my sensitivity is, I believe, around 10. And that's 10 millivolt per Gs. The coupling, that's kind of important because that's where we set up the CCLD for powering the transducer. So make sure CCLD is turned on when you have ICP or IEP or CCLD or Deltatron transducers. And under the ID, I'm going to put a label here, hammer. And I'm going to use Excel. All right. What we could do here real quick is to calibrate the transducers. So I'm going to pick up my teardrop accelerometer, the B&K 4517 accelerometer, the miniature XL, and I'm going to do a start calibration. So you see its system set the CCLD, it takes a few seconds to warm up everything. Up, it's measuring. Okay, done. So I inputted 10 millivolt per engineering unit. It found 10.97. So I'm going to accept and actually cancel this. I'm going to use the default 10 millivolt per G. That'll be easier. So okay, the accelerometer is back on the I-beam, one corner here. And that's it, I think, for that window, nothing else. Okay. The next thing here is the trigger. It's kind of an important one. So I'm going to use the analog input. Run mode needs to be auto arm at every frame. So every time I'll reach the trigger condition, I want to capture the time block and be ready for the next hit. So that's the right option to use here. Input 1. I'm going to use a positive slope. So I want to trigger when it's rising. Percentage is 1%, which is fine. Pre-post points or triggers. So I want to capture what happened, 20 milliseconds before the trigger conditions are met. And finally, I'm going to play with the averages. So I'm going to use a linear average and I want to average, let's say 5 hits. All right, so what do I have here on the screen? Well, I got the coherence display, which is nice to have. I can maybe minimize that a little bit. I've got the H1 magnitude and phase. Let's turn off the phase for seconds here. So under content, instead of log mag plus phase, I'm going to use log mag to make it a little bit simpler to look at. All right. What I really miss here is the time. So I'm going to say new window, 2D display, 2-pane horizontal, which I'm going to place just right there. Okay. On the top, I want input 1. And the bottom, I want input 2. So I will have my hammer. Okay. You see the unit, and I will have my accelerometer. You see the unit as well. Okay, I think this is it. I'm going to do start. Let's see what happened. So we're waiting for a trigger. That's good news. Going to hit the structure now. Well, I'm not very happy with the measurement here for few reasons. First of all, I didn't fully capture the response, the accelerometer. You see, there's still some ringing here, and I need to increase my time block window. So we can stop the analyzer and test. And actually, I'm going to double the number of lines, so that will double my number of points as well. And what happened also, I almost clipped, almost overload here. So I'm going to start again to hit gently. A little bit better, but not perfect. So I'm going to stop here. And I'm going to push my number of lines. Need to stop the test, go to 3200. Start. Much nicer. So you see now the curves looks a little bit nicer. It's not wiggling like we had before. So it could be improved, I guess. So I'm going to hit harder now. So now the coherence is showing up. You can see that for that given peak, we have a pretty decent coherence. The coherence drops here at the anti-resonance point. So you see every time I hit an anti-resonance, the coherence drops quite drastically. But where I've got my peaks there, I got a fairly good coherence. So another measurement here. Okay, nice. Yep. All right, perfect. So that was it. This is my quick FRF demo using RT Pro. Thank you very much.